So in this video, I'm going to be showing you how to use the digital multimeters that we have in our labs. Digital multimeter, also referred to as DMM in your lab manuals. So this is the version of the digital multimeter that we'll be using. It's got several different functions. I'm going to try to show you the most common ones in this video. So the first one is to measure a resistance. Now every multimeter has its own quirks and things like that. So I'm going to be focusing on that for this meter. So if you want to measure a resistance, and these are resistors, they're just like basic circuit components, they just basically slow down the flow of electrical current. But how much resistance they have is very important. So we want to measure resistance. Resistance is measured in ohms. So if you look at this part of the resistor here, you'll see an orange Greek letter capital omega, and that's the unit for resistance is ohms. So to measure that, I'm going to switch this dial over there to the ohms section. Now you'll notice that there's this speaker looking icon that's white, and the ohms icon is orange, and so by default it's going to be on that speaker function white. And now what that does is actually a really useful function as well. This is one of those things that having a multimeter in your toolbox at home is really helpful for. If you want to know if 2 points are connected, you just touch them together, and you can see that when there's a connection, you'll get a beeping sound. And that's what that speaker refers to. So any piece of metal, like this piece of metal, if I touch 2 points on it, it's going to make a connection. So it'll allow you to know that 2 points are connected. Now that's that speaker function. What we want now, though, is to measure a resistance. So I'm going to set the select button, and that's going to change it to measuring resistance. So down here you've got units of, right now it's assuming mega ohms, but we're probably not going to get that big of a resistance. So I'm going to unplug these, and to measure one of these resistors, I'm just going to stick it into the 2 ports and just kind of hold it steady. See what it reads. And this will automatically range down to where it needs to be. You can, oh, actually there's this light button here, so I'm going to turn that on. You can see that better. It's reading 159.3.4 ohms. Single ohms, not mega ohms. So you just want to make sure you have a secure connection. That one's about 160. Let's try this one. Stick the leads in there. That's gonna go, it's pretty small. Yeah, it's about 100 ohms, 99.9 ohms. So that's how you measure a resistance. That's pretty easy. You just have to make sure that you select onto that function when you're on the dial. Another thing that we can measure is voltage. So voltage. First of all, I want to switch over to this dial, the V, because that's measuring volts. And again, you'll notice that there's 2 different icons, one orange, one white, and I'll explain to you what those do. But for this purpose, we're going to want to use these leads, which come with any multimeter. So we're going to plug them in. We're going to plug the black one into the black slot, which is labeled COM, and that refers to common. So it's basically our reference point. Any other voltage is measured referenced to that point. So when we're going around measuring different points, we move the red lead, but the black lead typically stays fixed. Anyway, you can think more about that later. And I'll plug the red one into this one. There's another red port over here, but we don't need to use that right now. And then so on the other side, I've got these 2 leads. The leads typically come with a little cover, but you can just take that off if you're trying to make a contact more easily. So here I've got a 9-volt battery. It's a typical 9-volt battery. One side of it is positive, one side of it is negative. And you'll see what the difference is. Now, notice that if I connect this across the 2 terminals, what the reading is on the multimeter, it's 0. And it's a 9-volt battery, so I'm expecting it to read 9 volts. So why is it reading 0? The reason is because this particular multimeter, again, it's got 2 functions here. It's got an orange one. You can see it's labeled as like a straight bar with a dotted line underneath it. That's for DC voltages. But the default setting when you switch to voltage is this AC voltage, so it's like a sine wave. And that's what you would use if you wanted to measure the voltage out of, say, the wall socket. That's 120 volts of AC voltage. But for a battery, that's a DC voltage. It's just a flat voltage. It's either on or off, and it doesn't vary sinusoidally. So what we're going to do is hit the select button again, and now it's going to measure a DC voltage here. So you can see that it switches from AC to DC. For a battery, I need to know that it's a DC voltage. So then I go ahead and connect them and see what I read. So 9.22 volts, pretty close to what's advertised as 9 volts, right? Notice one thing, there is a difference between the red and the black sides. If I switch them around like this, notice that I still read about the same value, but notice that extra little bar above the DC, that's actually a minus sign. So in this particular multimeter, the difference between this and this is a minus sign. And the way the minus sign is indicated is just a bar over the DC, just I guess to save space. So be aware of that. If you're looking for something that's negative, you'll see a minus sign up there. Right now I've got it connected to nothing, so you can see that the numbers are kind of scattered all over the place because I'm not really measuring anything right now. Okay, and then here's a AAA battery. If you know anything about AAA batteries, you should know I should measure about 1.5 volts. So I'm just going to connect that. 1.5A2, notice the minus sign up there on the DC. That's because this is the negative side of a AAA battery, but I've got the positive side of my multimeter connected to it. So because I'm inverted like that, it's going to give me that minus sign. If I switch them around, now I get rid of the minus sign. It's the same number, but positive now. Okay, so that's how you measure voltages. So another thing we can do is let's set up a little simple circuit, since I have. So another kind of thing that you'll be using in the labs are these clips. So what I've got here is a couple of those 165 ohm resistors, and I've sort of chained them together. And the way these clips work is, let me see if I can get this out of here. You kind of press down on one side of the clip, and then you can insert this lead into that opening that's created, and then you let it go and it sort of holds it together, right? So these are a really easy way to make a simple circuit. Now the simple circuit that I'm going to make here is I'm going to take this 9-volt battery and I'm going to power it. I'm going to use it to power these two resistors, and it's just two resistors that are each 165 ohms, roughly 165, and I'm going to connect them to this 9-volt battery. And the way I'm going to do that is with these clips. So I'm going to take this wire, clip onto the positive side of the 9-volt battery here, and then I'm going to go into the first resistor by using this clip, right? And then out of the first resistor straight into the second resistor, so they're in series. So, and the reason I'm doing that is I want a lot of resistance in this circuit. I don't want to generate too much heat. And then after I'm done with the second resistor with this black lead, I'm going to go back to the negative side of the battery to complete the circuit. Now, when I do that, it's going to start drawing current, and all it's going to do here is generate a little bit of heat. So it's not going to really do anything useful, but it'll give me something to measure. Okay, so now I've got a complete circuit, and if I let this go long enough, I'll notice that these resistors are starting to get hot. But if I just want to measure one, let's say I want to measure the voltage across this resistor. I'm not going to get the full 9 volts because it's sharing that 9 volts with this other resistor. So what do you think I'm going to get? You can take a guess. I'm going to get 4.5 volts. And if I go across the other resistor, I get the other 4.5, right? And if I go across both of them, I get the full 9 volts, right? And the rest of it is taken up by the wires and the leads and stuff like that. But generally, that's how you measure voltage. You put it on voltage mode, make sure you're in DC mode, and then go across whatever it is you're trying to measure in parallel with the thing that you're trying to measure. If I go across this battery directly, then of course I'm going to get the 9 volts. And the same thing with switching the polarity, switching the leads around, you get the minus sign. What else did I want to show you? Well, here's a quick thing that I can show you. Another thing that these multimeters come with, and I'll just disconnect this circuit. It is starting to get a little bit warm. Let's put those aside. Another thing that you can do with these multimeters, which is really nice and convenient, and you might have occasion to use it, is this is a thermocouple. Comes with a multimeter. A thermocouple, as you can see here, is just like a piece of metal. It's actually two different types of metal that are fused together there. And what happens is when they absorb heat, they generate a voltage. And the amount of heat that they absorb determines how much voltage they generate. And so it's basically a temperature measuring device. And this is called a thermocouple. And you can see that the other end of it is a socket with a plus and a minus. And so if I connect it with the plus on this side and the minus on the common side, and then I switch this dial all the way over to the temperature where I have Celsius and Fahrenheit, you can see that on Fahrenheit it's 64, so it's 64 degrees Fahrenheit in the room right now. And if I touched it into something that was hotter or colder, it would change. For the most part in our labs, we're going to need to use Celsius, so I would select it over here and go to Celsius, and it's 17 degrees. One last thing I wanted to show you with the multimeter is, in case you have any problems like the battery runs out. Oh, one thing I do want to say is you can also measure currents. You can see that we have microamps, milliamps, and 10 full amps of current measuring ability on this device as well. You don't want to use any of those for now. If you want to measure a current, you'll have to get some specific instruction on how to do that, because you can damage the multimeter if you don't do it correctly. So don't bother using any of these three for now. If you turn over the multimeter, let me just turn it off. If you turn over the multimeter, if it ever runs out of batteries or if a fuse is blown, they do have fuses that can be damaged, for example, if you measure current the wrong way. If you need to change any of those, it's really simple. There's one screw here. And when I unscrew that all the way, this comes off, and you have two AAA batteries that are powering this thing, and then two fuses here, which you can pry up with a, and replace it with a different fuse if that ever gets blown. Fuses are pretty cheap, so it's not a big deal if we have to replace one. And then we can just kind of put this clip tab back in there and then screw it back on. So that's a quick tutorial on how to use these multimeters in the labs to make the common types of measurements that we'll need to make.